So here we are going to demonstrate about wireless power transmission to the vehicle, and the major components of our project are robo setup, where it is been used to display the voltage and current present in the battery. At the same time, this entire system will be working on the lead acid battery, which is 4 volts 1.5 amp, connected in series, totally become 12 volts 1 amp, giving input power supply to the Arduino, to the voltage sensors, and to the LCD display. So this is an 16:2 LCD display where the voltage and current can be distributed with the help of an regulated power supply section. Initially, this battery is going to give input power supply to the regulated power supply board, through which it is going to convert 12 volts DC to 5 volts by using an 7805 regulator IC. Before that, there will be a capacitor to give a constant voltage, and after that also there will be a capacitor to show the constant voltage, LED to indicate whether this section is working or not. And the output voltage from the regulator IC will be going towards the UNO, where the microcontroller is going to give read the commands coming from the voltage sensor and sending to the Arduino, from which it is going to give an output display by showing the voltage and current. So there is a clip over here where you can measure the different voltage value. Right now we have placed at 8 volts point. Now we can shift from 8 volts point. So by removing this clip and placing at this, so there again you can see the drop of voltage to 4 volts, and the ampere rating also dropped to 1. So like this we can measure the voltage present inside the battery of the vehicle by using this voltage sensor at the same time to the LCD display. And here we have the wireless power transmission receiver circuit board. So generally an wireless transmission happen between two coils, which is the primary coil and the secondary coil. So here at the bottom you can see the secondary coil, and here you can see the primary coil. So where it is going to generate the electromagnetic flux with the help of the circuit. So coming to this transmission section, let us discuss. We are going to convert 230 volts AC to 12 volts AC step down, and giving input power supply to the regulated power supply section board, where again consists of an bridge rectifier, 1000 microfarads capacitor, 7805 regulator IC, and the capacitor after it. So these voltage will be given as an input to the wireless power transmission circuit. So where we can see two sets of power supply being given to the circuit board, where this consists of an IRF Z44 MOSFETs. So these are two sets of MOSFETs which are going to convert the DC power supply source to AC. So which is nothing but to convert into a pulse rated DC. Usually we will call it as an AC. So that pulse rated DC is again being given to the coil. So initially these consists of an totally 3 terminals. So here you can see the middle terminal is the center terminal, and the two are coming from the MOSFETs. So here you can see a primary side, and this is an secondary side. So these two MOSFETs are going to give input to the coil, and the resonance which is coming from the tank circuit is given to the center terminal, through which it is going to generate the electromagnetic fluctuations. So if you place a metal in between this coil when it is very much close, or else a high dense material, then the metal starts to heat, whereas if you place our hand, it doesn't happen anything. So why? Because it is being mutually inducted to the secondary coil. So here you can see when we place the coil parallel to each other. Okay, now the mutual, with the help of this mutual induction, so here the LED is being glowing, which means the voltage is being transmitted. So like this you can see the height. So at this point also it is able to receive the voltage. So like this, with the help of this mutual induction, we can able to receive the voltage, and the same thing we can place on the surface on the road. So when it passes from coil 1 to coil 2, where again there is another section same similar to the first one. Okay, there are two MOSFETs which is being giving input to the coil, through which again it is going to receive on the secondary side. So this is how the wireless power transmission is done, usually in our mobile phones and also in our project. So here we are going to use this LM225 boost converter. So whatever the voltage coming from this wireless receiver circuit is again given to the booster circuit to increase the voltage and store the voltage into the battery. So this is how we are going to demonstrate. The same thing happens in the transformer also. At the primary side there will be an more winding, on the secondary side there will be an less winding. So this is called step down transformer, and whereas the primary coil and the secondary coil will be parallel to each other, then only the voltage will be transmitted. By using the same phenomena, here we are going to demonstrate the wireless power transmission system. So where we are going to not doing the huge voltage which is an alternative current, we are using the DC current to charge the DC battery power supply. Thank you.